Hello, everyone. Today is May 12th, and welcome back to Latio on the Record. Today, I am super excited to have an actual technological expert on with us, Daniel Pacak. Daniel, where are you calling in from today?
Yeah, I'm calling out of Warsaw, Poland, and I'm glad to be here today.
And with me, as always, is Charrah.
Hello, hello.
So I want to get started with just your background, Daniel, is super impressive. Basically, the way that we met was I feel like it was just every company working on cool eBPF stuff that I was digging into. I saw your LinkedIn teddy bear picture showing up behind. And so can you just talk a little bit about how you got into eBPF engineering and sort of your journey with that so far?
Yeah, absolutely. The teddy bear is actually a present, a gift for my son when he was born 6 years ago. So for me, it's easy to count the years I spent in runtime security or security. So at that time, I joined Aqua Security. This is the time when Liz Rice, she was building an open source team. And this is where I started really contributing into open source and getting interested into, let's say, static vulnerability management. But I quickly realized it's not enough, right? Being in the trenches, being on the security vendor side, I wanted to understand more and see what's the real value. So I wanted to join the team of Tracy, still at Aqua. But at that time, I think Aqua was pioneering or maybe following a little bit what Falco did. So it wasn't enough for me. I wanted more action, more like a breakthrough or like a completely different approaches to security. And this is how I joined Cycode, which was around the time when, supply chain security, if I remember correctly, there was a code coverage or SolarWinds, all this kind of laser focus on CI/CD pipeline. And with Cycode, we built the agent and action. Something very similar to Hardened Runner, the very popular open source alternative. I don't know if they use eBPF, but at that time with Cycode, we wanted to use eBPF.
I like to always joke how like the there are so many security tools that are just ahead of their time. And I mean, you built Simon quite a few years ago, but then all of a sudden you see step security with like the TJ Actions reveal, and all of a sudden there's a lot of interest in it. And I feel like that's just how the security industry works sometimes, where there's just suddenly like all of a sudden we really need this thing.
Yeah, I do have exactly the same feeling about Cycode. It was like probably we were too early. But on the other hand, like a Hardened Runner persisted. They just started supporting, self-hosted runners, and then they are growing a lot. But it is what it is. I also decided to move on into detection and response and really blocking the attackers, right? Because no one was really paying enough attention to the CI/CD pipeline. And also there was a problem of the context and linking, the source code with the backend. So on one hand, you could protect the CI/CD pipeline, but there is a huge gap between what's actually running in the cluster. You don't really know how to connect the dots. So I was like on my journey to find a real hotspot. So which is a backend, right? You want to attack the backend, maybe not just the CI/CD pipeline. So then I moved to RAD Security, where I came with, all the experience of unboxing Falco, Tracy, Tetragon, something very similar to your Latio website and posts. And when I read them, I said, oh, this is my brother, because we have the same opinions, like a Gartner acronyms are pretty misleading in a sense that they are valuable, but for the practitioners or people who want to really jump on this technology, start implementing agents, they are pretty useless, right? It's very hard to distinguish between SAST, DAST, ADR. Even for us internally, we keep arguing.
Do you feel like as you're coming to the conclusion of we need to focus more on the back end, we need to invest in all of these areas, are you pitching to companies? Do they understand like the technological importance of investing in these areas, or are you kind of finding you're pitching these ideas, you're having these aha moments, bringing them to companies, or the companies kind of finding you to start investing in these areas?
I think that's a great question, because I think this is, I've been recent years working for or contracting for startups, and I think this is a lot of depends on the founders, how they understand the problem. If they're just following like a copycats or following the trendy buzzwords, this could be the problem, because one company over the year can turn their focus from eBPF to AI, which I'm not saying is good. I'm not saying it's bad, but I think we are talking about eBPF today, which requires a dedication and a lot of, I think, investment and focus and its ongoing effort, because the whole Linux kernel and this eBPF module, which is part of the Linux kernel, is a complex topic. I'm not too usually joining companies to pitch the technology. I'm mostly interested in solving the real problems. And the real problem, attack detection or intrusion detection is, I believe, not just runtime, it's a hybrid, static, binary source code analysis. So like it's mixing all the holistic approaches to finally answer the question, am I secure or not? And that's my approach.
And then, so if I track your history, is this correct to frame it this way, where first it's working on Tracy, which is more of a Falco equivalent, where it's heavily rules engine based, and then going to Cycode and working on eBPF for a very specific implementation? Because baselining CI/CD runners is a super difficult challenge because they do similar things, but they make changes a lot too. And there's so many different workloads running on the same node that I just imagine it's a nightmare to deal with. And then doing baselining more broadly at RAD and now at Miggo, can you talk a little bit about what the sensor development looks like there?
Yeah, so you summed it up. Well, like a CI/CD is tricky. Just to quickly add one more thing, it's like a remote code execution by design. This is how we code CI/CD pipeline. So it's very hard to write a signature where any code execution is allowed by design. So having this experience with different approaches into signature-based behavioral analysis, facing all the challenges of not just developing the sensor, but also processing data on the backend side, finally met Goldman, the co-founder of Miggo. He had some very similar approach to mine. Like, we shouldn't just choose the technology. We should choose whatever technology is there, mix it, add more context. And this is where I started learning about ADR. I didn't even know about the acronym, but I knew also from your very technical post that like a CNAP or all the acronyms or cloud detection, I don't even try to remember.
WPP, CDR.
Yeah. So what I remember from this is that those tools observe a perimeter. So they are good maybe to do like a post-mortem or maybe see that there was an attack, but where it comes from, what's the blast radius, you are still losing a lot of details. Whereas the ADR or whatever acronym will have is like looking from the inside. And I couldn't understand it, how I can look at the application from the inside until I met the founder of Miggo. And we talked a little bit with Liad, who's the lead of security research. So we started discussing, and it was for me like a click moment where I said, okay, this guy's trying to do something maybe not completely new, but out of the box. And this is how we are trying to build a real ADR or CADR. I don't know yet if we are there, of course, but this is our main focus.
So let's I want to dive into so many things there, but we should, for the audience's sake, back up and do a really high overview of what even is eBPF, what's made it really take off in the last few years, and that sort of discussion.
Yes, I've recently done the intro to eBPF for the team, and it's very hard to explain it. It's very broad, but the simplest I can think of is really a virtual machine running in a kernel. Historically, I think it was the TCP dump or network sniffing that, you can imagine that there's a lot of network traffic in the data centers or even on your personal computer. If you are trying to capture all this traffic, not to mention like a query this data, it has to be performant. So like there was an initiative historically, people rewrote the sniffer and they decided to use this VM. So the code was fast and secure, kind of a sandbox. It was a hell of effort. And they quickly realized that, okay, we have this machinery, so why not just trace network? Let's do other stuff. So this, I think, at least my understanding is that it was a good foundation to build other types of eBPF programs, because there are many analogies like JavaScript and HTML, like you want to extend it. We want to plug some custom code. And this is exactly where eBPF is good, right? You have a Linux kernel, which is monolithic architecture. It's well maintained, but it takes time. It's very complex. You have to be a good guy to be the maintainer, to persuade, to merge your patch. Instead, you can just run your custom code. For example, we can add some security sensor that is tracing a network or tracing a new program being spawned. I wouldn't say simple, but there's maybe a little bit shorter path to do that than contributing to the upstream kernel. So for me, eBPF is...
Let me ask something, even in what you've described so far, where some pushback I get from people who are like really in the eBPF weeds, which I realize is like, 5 people maybe, is that it was originally designed primarily for network observability, as you were describing. So is that true? Is it really, are we misapplying it to move into security with it? Or are these just natural evolutions of like the use case of the new way we can interact with the kernel?
That's a very good question. And I'll be always on the engineering side because I know how complex it is to deliver such a big and complex project. So I think eBPF, we should think of it as a incrementally delivered feature which indeed started with a network, but now it's a good foundation to extend it even outside of Linux to like a Windows operating system, which I think is far, far away, but there is such a process. So we need like a short-term goals and like a big plans. I think it's not misuse or misconception. I think we just need maintainers and contributors to mess with this very low-level stuff, to not just wait for the features to be implemented by the maintainer, but give feedback, use it, and ideally contribute, right? That's I think the way to fit this ecosystem and make it easier for developers to use, because right now it's a bit tricky.
Gotcha.
So are you saying, just to make sure I understand, are you building these things 0 to 1? So you mentioned that it would be easier if there's like an open source community or a maintainer or just more contribution from a public standpoint. So when you're entering a company that wants to focus on eBPF, are you doing 0 to 1 builds, or how does that work?
I think if I compare it to the backend developer or front-end engineer, you're usually using frameworks or SDKs, you have nice debugging tools, etc. If you start developing eBPF programs, things are getting a little bit shady, right? Because first of all, you need a Linux VM. Most of us are using maybe Mac OS or Windows. You have to do this virtualization. Then we are going to the orchestrators, for example, Kubernetes. Like a kernel doesn't know anything about containerd, Docker, Kubernetes. So like every vendor now writes their agent or copies code from the open source projects to enrich very raw, low-level runtime events with container metadata. So I think the biggest pain point, of course, that's probably more than I could recall, is that there is no SDK. You can't just easily use the library. There's a lots of duplicated code. There's, as I said, the development environment. We are actually evaluating how Cursor is going to handle the eBPF and Go kind of, polyglot repositories, but those like main challenges. It's not, to answer your question, it's not like we are writing everything from scratch. There is a eBPF sandbox, so kind of a contract. There is a bytecode that eventually when you write the eBPF program, it gets compiled. So it's there, but to get there, to compile it, I think many choices, but only 2 of them are kind of a production ready or mature enough to deploy it in the customer environments.
There's 2 questions I really want to follow up with here. One is, how common is that open source starting point for people? Like, are most people starting with something like Tracy or Falco and then building on top of it? And then I've got another one.
Yeah. So this one, quick, honestly, everyone, I think, because they typically wrapped in open source, it's easy. I think it's reasonable. You don't have to hire like a Linux kernel maintainers or people who are obsessed with eBPF. It's relatively easy, but quickly they realize it's all the downsides. So I think it's a good exercise, engineering kind of a hackathon, but it's not something to build a product out of unless you know how to customize it, tune it, etc.
So that's one of the most common things that I hear all the time is people get like, Wiz has eBPF or Aqua has eBPF. Like people just equate everything as eBPF. But then to your point around the lack of a framework, the thing I was the most surprised by, just trying to like dive into it a little bit, was basically, you get an IDE open and it's like, go ahead and write some C. And I'm like, all right, well, this is a blocker from part 1. How different are each of these eBPF applications? Like, are they from the ground up, like totally unique as with the duplicative coding that's happening? And is it like really the Wild West of just insanity?
Yeah, so I think it should all start from the product, which I know for developers is not always the fanciest things to do. They just want to attach to execv, open it. So then the answer to your question is like infinite options. If we look from the acronym standpoint, what you actually want trying to build, are you building a WAF solution? Are you building a network intrusion system? Are you gonna build file system integrity checker? Then you start narrowing down all the hook points in the kernel. Kernel is very complex, right? There's virtual memory management, how programs are loaded, compilers. So I think you have to be focused. If we are talking about ADR in particular, we are more interested in what's on the execution path of a given application. So I'm less interested in network sniffer, right? We would rather look at some stack unwinding things, right? Without like revealing too much of what we are doing. But you can imagine that there are certain programs or eBPF program types that we are implementing. And coming back to the open source initiatives, of course, we are getting inspired from time to time. There are good donations to the open source team of the companies that probably dropped some ideas, or maybe they can't maintain them. So we're also leveraging that. But in order to leverage the open source product or customize it, you really have to understand it deep dive. the kernel, how it's going to use it, all the implications, etc. But the experience is pretty the same. You have to know how to set up the development environment, which is still not easy. Not everyone across the whole team, like they claim to be full stack, still they don't know how to run the sensor in the local environment, which I'm not blaming people. It's coming back to this problem of the ecosystem. It's not like a user space app. It has to improve.
I mean, the tackling the skill set issue seems like its own massive challenge. But then when it comes to even conceptualizing what can be done with eBPF, I mean, what's the right way that we should think about the possible use cases? Because we talk about a lot about the function level reachability stuff that ADRs are doing with the stack unwinding, if we can, leave it at that, because but it seems like even there, everyone's using a different methodology to get into sort of the same ballpark of solutions. And then I've always heard that the network layer 7 part is its own massive challenge to overtake. But are there just also totally, like, can eBPF really be used to do anything, or what's sort of the box we should think of these solutions as being capable of?
Yeah, gotcha. So, very good question. We have this discussion last week, this week, even if it just started, maybe one by one, like while level, like layer 7 is tricky with eBPF, right? So for those of you who know how the TCP IP stack looks like, at the end of the top of the stack is like you have those protocols such as HTTP or gRPC, right? So they're pretty complex binary protocols that you have to parse it. And usually when you develop an app that parses a network packet in the user space, you have a library. You just go to GitHub. That's it. But we already said earlier that there are no libraries in eBPF. You have to somehow copy this code from somewhere. And even if you copy it, because there is Touchdragon parsing gRPC or Falco, whatever, or Tracy. So I call it analogy-driven development. So hopefully you just copy the comments or give credits to the maintainers. But then you run into another problem of eBPF. As I said, it's a sandbox. It's like a VM. And to be secure, right? The Linux kernel maintainers are very smart. They didn't want you to run any Wild West code in the kernel. So there's a limit of the number of instructions that you can execute. So what does it mean? It's like you can't loop, like there's no tomorrow. There are many constraints. There is a bunch of BPF helpers or functions. So really tiny list in comparison to what you can do in the user space, to what you can do with this program. So some people will tell you during the conference, it's Turing complete, you can do everything. But in practice, I think I can say it at Cycode, we parsed DNS, requests and responses, and it was horrible. I had to use tail calls because I was getting into those, instruction limits. So the code has to be split in a very smart way so the verifier accepts it. So it's not an SDK, right? It's kind of a workaround driven development, but to the point I said, we should give this feedback to the maintainers and maybe increase the instruction limit, or maybe we should have a way to add those kind of libraries or modules or whatever to Linux kernel. So our life is easier as vendors.
Well, I realized we started diving into the details before finishing the high level explanation. Let's see, what is the difference between kernel space and user space, and why does that matter for what we're trying to accomplish here?
Yeah, very good question. So like modern CPUs are running in multiple modes. Some of those modes are kind of a privileged mode. This is done for efficiency and for security, where your operating system is really guardrailing the hardware and everything from user space applications that can be malicious or can be just buggy, right? So this is the isolation by design, how modern hardware, like a CPU and operating system, is orchestrating all the applications on top of that. So the user space application is really using an API, right? Kind of a bunch of system calls, an interface to do anything more critical, such as opening the file or opening a network connection and all that, and or talking to the particular disk drive. So in order to see what the applications are doing, you have to attach, your eBPF programs to the kernel, and this is where the user space and kernel space difference becomes apparent, right? So the kernel space is managing some memory for all the processes that are running in the user space. So I hope it's not going too crazy into the details, but this is like giving the basic explanation.
So you've been talking about what it takes to kind of get it stood up, why people want to invest in it. But then you mentioned that different companies also use eBPF, even though they're focusing on different things like the perimeter. So why are people investing in eBPF? Like what happened, I guess, like you're mentioning the ways to use it. But why is this? I feel like on the marketing side, if you go to a website, everyone's talking about eBPF. And I feel like it kind of came out of nowhere. Before it was real time and now it's eBPF. Why are people investing in it right now, do you think? Or like what makes a company want to invest in it?
Yeah, that's a good question. Maybe James, you have some thoughts about it. My experience from the field is that maybe Kubernetes administrators realized that the previous solutions like LD preload or other hacky or manually instrumented applications are no longer an option. And this is where runtime security or zero instrumentation solution became more popular. But other than that, I don't know what's the reasonable explanation, except of course saying that you're in the category of the product.
I mean, I think two of the primary issues with security teams installing agents is concerns about performance or reliability and then the detection quality. And I think eBPF just from I don't know a lot about how pre-eBPF Linux agents were instrumented. Honestly, I think for most of the security industry pre-eBPF, people would like risk exempt their Linux boxes as saying, oh, it's Linux, it doesn't need runtime protection, or they're using like ClamAV and doing basic signature-based malware detection. But just the detection quality was so bad across, and it still is really bad across anyone who's not like a modern vendor. There's every time I've evaluated an older solution, like a traditional EDR on a Linux, specifically on a containerized Linux box, I've just thought it wasn't working because I could do the most heinous, crazy stuff and it just wouldn't detect anything. So there's the detection quality's gone way up, and then the reliability concerns, just the performance overhead is so much lower. It's not crashing the applications. And that's actually what I wanted to talk about was the number one objection from a security team for installing an agent is that they're worried it's going to break things. Does eBPF actually fundamentally change that conception, or is it, what's the real answer?
Yeah, so I think that by design, in theory or in the books, this whole eBPF virtual box is sandboxing the code that the security vendors are running. However, another part of it, I think, which is the tricky part of this design, is you have to attach your eBPF programs to a certain places in the Linux kernel. And you can go very wild because if you use kprobs, some type of the program that allows you to attach whatever code to a symbol or a function that is running or in the live kernel. And for example, this operation is very frequent and you are not aware of it, or you are deploying it on a cluster that is running a particular workload that is bound to, let's say, CPU or IO, and then your program gets triggered very often, then indeed the eBPF is efficient and it's secure, but your program or the way you use this whole thing is super inefficient. So I think that's something very hard to explain. We struggle. We put a lot of consideration ourselves as engineers where to attach to not flood our backend system with too many events. On the other hand, we want to see enough to not have a blind spot, right? Which is another. So it's always like a trade-off. This is why eBPF engineering is hard, because you have to really understand the kernel, not just all the complexities of setting up the IDE for eBPF development. You need to come with expertise how to learn how to attach it. And referring back to old school methods like maybe systemd or other auditing solutions, I think eBPF is also prone to the same problem because, as I said, it is running, whether it's old school or eBPF solution, it's running in the kernel. Kernel doesn't know what is a Kubernetes, doesn't know what's a containerd. And let's be honest, container is really a patchwork, right? It's a different parts of the user space and kernel space things working together to, well, how to say it nicely, to give you impression that this container is secure and isolated. We know how easy it is. Maybe it's getting more tricky, but it's quite easy to break those boundaries, right? So I think data enrichment. This is the same problem that we used to have, which is not solved, right? You have to, as a vendor, implement a code that associates execv or syscall to a particular Kubernetes pod, for example. So I think there are some things that were solved, but there's plenty of open questions. And this is why so many vendors, to your original question, James, tackle this problem differently. I think they are learning, trying different things, and that's why we are ending up with relatively small, but yeah, I know there are alternative solutions to the security.
You mentioned earlier that there's a small subset of experts in eBPF who kind of geek out on this. So when it comes to different tools, building it differently, creating different type of bloat or disruption when it comes to implementation, for the security engineers that are a little nervous or hesitant to implement something like a sensor, what is a way for them to kind of either confirm or go about assessing if this sensor is right for their specific environment? So since everyone's talking about eBPF, building it differently, what is a sure way to say this wouldn't be disruptive, this wouldn't cause bloat for a security engineer that's ramping up on eBPF?
So I think, again, I think James has a lot of experience unboxing all the different solutions and vendors. But from my standpoint is you have to show the real numbers. You have to show the POC that's not, burning the data center. Right? Don't install it in a Minikube cluster. Just ask a customer for the EKS cluster or production grade cluster and show that you are implementing these programs in a way that's like a very defensive programming, that it's fault tolerant, and be honest about the limitations. I think many vendors claim that they are using runtime solution or eBPF solution, and there's like we block 100% of attacks. We are doing our best, but as I already mentioned, it's a trade-off. Of course, we can attach eBPF program to each and every function in kernel and see everything, but then AI and ML or whatever new acronym will be there in 1 year will not make any sense of this data. So for me, always a proof is the good POC, POV with real data and agent that's not crashing existing workloads, and it's running for at least a couple of days. So just don't run it, install it, and go away. Just install it, leave it there, come back in a week and see what kind of alerts we are showing. This is
how many more nodes Kubernetes had to spin up, and your cloud spend has gone up because of it. That's I think one of the challenges that I have just trying to test solutions. I mean, it's part of why I have a test bench that's EKS instead of like Minikube or anything. But I've got maybe like 5 or 6 security agents installed at a time on the nodes, and I need to like give these things massive amounts of memory to try to compensate for all of them. And I definitely feel like the memory utilization is where I see things get out of hand the most. Does that jive with your experience as a thing to watch out for?
Yeah, this is very good, I think, test for the vendor, because some vendors will tell you just need add 4 more gigs of memory. And sometimes, the agent will not even get scheduled by Kubernetes because of limits on the node. So of course, we can't add memory to infinity, but this is the problem of implementation. Why out of the box or open source solutions are not always suitable. Again, without the names, some of the solutions decide to do a lot of policy or signature evaluation on the node. This is why most likely they will demand more memory. On the other hand, other vendors will try to push this data out of the node, so they don't need that much memory. Of course, they are becoming near real runtime security solution. And again, you should be able to understand the difference, right? But then there is they have more space because they pay for the memory, right? In their backend, in their SaaS. So I think those are the subtle differences that are very hard to explain from the marketing standpoint, or just in a very short conversation. You have to start going very deep to find those subtle differences. And my experience is that those subtle differences can break the whole security solution, really. There is a leader in eBPF. Again, I give credit where the credit is due. That's why I won't name this company. But I think they have a very bad architecture because of the reason I said, right? They're trying to do too much things on the node, which first of all is prone to memory issues, but also they don't have enough context, right? This is why all these new categories, ADR, CADR, whatever, is an interesting area.
I want to also address something that I hear all the time from people is an unbelief that eBPF can get function execution data. And this is like a weird objection because it means that you like know enough about eBPF and what function execution data would even mean to like have this objection. But I'm curious like why you think that people find it unbelievable. And then what's sort of the way that you could convince someone, well, hey, we're doing it?
Yeah, I think everyone who gets started with eBPF goes to BPF tools or BCC framework, and they have a bunch of examples, so you can start running them, playing with them. And there is I think, example program for getting the stack trace. But when they print this stack trace to the, STD out, they see function address or random numbers. So basically the stack trace is not symbolized. And I think this is the biggest challenge, right? Because to do the function executed or see what is the code path executed by the running application in the data center or in the server, you need the symbolization. I think that was the tricky part, right? Because, well, developers, they like to save space. So they strip out all the debug symbols. This is just for everyone who is not that familiar with these details. So like when you compile your program, you have an option to include all the debug symbols. So it's additional metadata that is useful for debugging applications. So when I'm developing app locally, I don't usually care, so I can have those symbols, but there are good reasons to strip this out, right? So then there is a problem. How do I capture the stack trace and then symbolize it? And maybe this is the only reasonable way for me to understand those skeptical attitude. I can tell you there is a way to symbolize the stack trace, right? And this is what other vendors, including Miggo, are doing. And it's not also reinventing the wheel. I think there's a good open source project or other initiatives that you can leverage. As I said, they are probably not ready to go out of the box because, for example, they can be suitable for profiling or tracing the whole host. Making this suitable for the containerized environments is another story. And we already talked about expertise or a little bit deeper understanding of all the bits, but it is possible. I'm not sure it was convincing enough.
No, I think even more basic than that, there's this thing that I run into where people just assume that the separation between kernel space and user space is like absolute, and that there's no way to see what's happening in user space at all. And I mean, honestly, I think this is where I always just go to showing it, I think is the answer from vendors that I've always found the most impressive, because it's like, I can sit there all day and say, that's not true, that's not true, that's not true. But then when I deploy it and I see, look, it saw the function execute, that's sort of the moment, I think. All right, let's move to talking about when it comes to implementing eBPF for security teams. How should people go about trying to best utilize this technology in their environments? Should they try to spin up their own eBPF, experiment with something open source, go straight to a vendor? Like, what's the range of things that are out there depending on how technical your security team is?
Yeah, so I think my advice, I think I took all the wrong paths to this, maybe some of them, because I started learning where there was not the book by Liz Rice, which is called Learning eBPF, which I think is a great starting point, where you have some theory, some examples. Those examples can be compiled and you can, let's say, run them. Before that, all the knowledge was like a spread across the internet. I already mentioned BCC or other kind of maybe libVPF bootstrap projects. So I think it's always good to learn by doing and having some kind of a foundational theory behind it. But as I said, this is like a Linux kernel, so I think it's also very useful at least understand the Linux kernel architecture. Otherwise, you will be blindly running some programs that print to the standard output. You will never feel it and understand all the challenges. But as a starting point, I think it's good. Once you pass this path, I think, many times I'm an engineer for nearly 20 years. And I publish very rarely because there's so much great articles to read that we usually overlook. So what you do on the Latio attack, like unbox, understand, learn from the mistakes by other vendors. This is, I think, great opportunity because you can just read, understand, maybe not every line of code, but understand high level. What is the category of this product? Is it unique? Is it the same? Is it just Rust instead of Golang? Because there are many products that are exactly the same, just rewritten in different programming language. Even I was doing this, like a rewriting from Python to Golang. I won't tell you which company was that, but it is a real thing. So yeah, go and try Tetragon, a great place to get inspired, right? Whether it's a security tool, I won't tell you, but it is a bunch of very useful code snippets that are running in the kernel, right? So that's my approach. And then come join us maybe to build together the next gen ADR, because we're also looking for eBPF engineers.
Sorry, I just want to also spotlight that prior to you like spinning up eBPF, there were no resources, there were no books. So you just kind of were super scrappy and just invested in it. I think that's so insane, just given how technical eBPF is. And now you've kind of become this resource, I would say, that people like know that you're kind of a eBPF legend. And prior to you, like what resources like were out there, what pinpoints or reference points did folks have? So I just think it's really cool that you've been spending so much time kind of perfecting this and doing the groundwork to better understand what are the edge cases, where does the tooling stop, what investments do teams need to make. I just think that's great.
Yeah, and I think the credit also goes to the Israeli startup founders. I think Cycode was the one. I told these guys, I don't know this eBPF technology yet, but I know it's super cool and I can learn by doing. And this is how they trusted me. And this is how I became like building this knowledge. So it starts somewhere. It's not, you can't do this overnight. I think it requires dedication. But then once you master all these pieces, then you can discuss and see where it is useful, where it is not. So of course, it's not a silver bullet, but it's a good weapon to defend your servers, for sure.
One just real quick to end on you saying that you're hiring eBPF engineers. I'm sure every cybersecurity company is hiring eBPF engineers right now. Do you think it's a good skill to learn for developers who are in the business of trying to make money and have good jobs?
That's a good question, but I will leave the answer to individuals. I think I was thinking about this type of question before we met today, and I compare it to the iOS developer. What is the difference between Java developer and iOS developer? The pay is the same, but iOS, the hardware is 3 times more expensive, right, than the Java developer can do. So for me, eBPF is like a iOS++ developer, right? We've been talking about kernel, C, even without going much into the details. You can imagine there's lots of technologies. Something that we haven't talked a lot is what you are doing with all this runtime insights or the backend sides. I have a privilege to be part also of the data processing pipeline because I knew from the very beginning that I can write maybe efficient sensor, but the backend team will struggle processing this data. So we're really trying to design this from the kernel to the, alert, the whole data processing pipeline. And this is like some of the previous companies and places. I think people didn't realize that you have to be very careful where to throttle this data, where to deduplicate the data. I think this is modern runtime security. Even though we are talking about eBPF, it's also a big data problem, right? How to prison or, make sense of this data, how to run detections, where to you run those detections. And so I can't advise. It's for sure very, very interesting and very challenging. I personally find it very, very fun and interesting because I love knowing how those little bits work together, from compilers to the kernel and also to the user space. So maybe this is a pretty unique skill set, but it gives you a lot of powers because if you know how to trace a program in the kernel, you can be also a very good user space developer, right? Because lots of these techniques will make your backend or even front end work much, much easier. So even if it's not full time, it's good to try this out and do like an exploratory path. Just try this.
Well, it really does feel like a EDR 2.0 because these conversations just seem so similar to how do you build a proper scalable EDR.
I think the thing that's so important that you both are hitting on is why do you need this? What are you going to do with those insights? And as teams think about tools that they want to introduce to their stack, I think sure, on one hand, for security engineers, understanding how we build this, tapping in the right folks like the backend engineers, making sure that the process is smooth for the experience of a customer. But on the other hand, for customers, understanding if you were to get these insights, how does it couple with the stack you have and what would you do with it? I think are such important conversations to have, given this is new technology, given that it could be disruptive depending on the vendor that you're using. Just really having a pulse check on the why behind it on both sides.
Yes, and in typical engineering fashion, we did not spend a ton of time on the why. It's more because we assume the why, which is look at all this gnarly attacker stuff you can detect, whether it's at the application layer, the container layer, Linux, like the possibilities are truly insane. And that's what I get so excited about with it. And I'm sure you're the same, Daniel. So, Daniel, where can people follow you or keep checked in on the latest?
Yeah, I think the latest and still up to date is GitHub. I'm an engineer. I'm trying to contribute to the open source. So GitHub and LinkedIn. I think those are the 2 platforms I keep maintaining and posting interesting stuff, not only about eBPF, but mostly about eBPF.
And please keep me honest on LinkedIn because you're talking to a guy who doesn't know C, who is opining a lot about eBPF. And it's helpful to have people who actually know what they're doing chiming in. So thank you guys for tuning in.
Yeah, thank you very much. It was great.